Hi, I'm Sonia. I'm going to present our work MOPA, Modular Object Navigation with PointGoal Agents. In Embodied AI, the task of navigating to a relative target location in a visual environment has nearly been solved. In this work, we ask whether we can effectively reuse this skill to do more challenging semantic navigation tasks such as object navigation and multi-object navigation. To this end, we propose to use pre-trained PointNav agents for object goal navigation tasks. To implement this, we develop a modular approach called MOPA, and we evaluate MOPA on a newly introduced Multion 2.0 dataset along with Multion version 1 and ObjectNav version 1 and 2. We show that MOPA outperforms alternatives without having to be retrained. MOPA is a modular approach which contains 4 main modules. Each module is responsible for a specific task. Next, we look at how these modules work together to perform the multi-on task. Multi-on is a generalization of the single object navigation task. Here, the agent needs to find multiple objects in a particular sequence. The agent starts by observing the environment through RGB images. The object detection module identifies if there are any objects in the current frame. Initially, however, the target is not visible to the agent. And so it needs to search the environment. And this is done by the exploration module. Next, the navigation module generates the low-level actions to move the agent from one location to another. As and when the agent observes an object, it memorizes it on a map through the map building module, so that it can come back to it if it appears to be a future target object. When the target is visible, the agent navigates to it. This process continues until the agent has discovered all the target objects. Our model takes in RGB image, depth image, agent pose relative to its starting position, the current goal category, and generates one of 4 discrete actions. The modular nature of MOPA allows us to use different learned and traditional methods for each module. Our navigation module takes as input the relative goal position to generate discrete actions and can essentially be translated to the PointNav task. This allows us to reuse a model that was pre-trained for the PointGoal navigation task. Next, we perform ablations on the navigation module by comparing PointNav agent with the analytical shortest path planners used by the prior works. We find that the PointNav agent not only outperforms the rest, but is also significantly faster. We also perform ablations on the exploration module by comparing various learned and heuristic-based approaches. Stubborn is a heuristic-based method where the agent selects the 4 corners of a local grid around itself. We also use the popular frontier method where the agent navigates to the frontier of the previously explored regions. Next, we compare with active neural SLAM, which is a learned method to predict an exploration goal to maximize coverage based on the agent's pose on a free space map. Next, we introduce a simple heuristic-based method called uniform top-down sampling. Here the agent samples an exploration goal uniformly on a top-down 2D map. We find that our uniform sampling-based strategy outperforms the others. We show that MOPA can effectively address both ObjectNav and multi-ObjectNav tasks without having to be retrained. We also show that MOPA transfers to unseen environments better than the end-to-end models from prior work. Our pretrained model achieves similar performance on both MP3D and HM3D scenes, with and without distractors. We perform an error analysis, and it shows that most of the episodes fail due to the agent running out of steps. The rest of the episodes fail for stopping far away from the goal. For the first case, the agent either has not yet seen the goal or has seen the goal but fails to stop close to it. We did a similar analysis for ObjectNav task as well. It revealed that some of the episodes fail even when the agent is near the goal and the goal is visible. This indicates that the viewpoints sampled for calculating success in ObjectNav are very sparse. To summarize, we introduce a modular approach called MOPA. Its modular nature allows us to combine various learned and traditional methods. Reusing PointNav agent can effectively be applied to complex semantic object navigation tasks, and doing so saves millions of steps of training. Thank you for your interest in our work. To find more details on MOPA, please check out our paper.